Hello, my name is Junseo and I'll be presenting our work, NeuRex, a case for neural rendering acceleration. Neural rendering is a new and exciting technique that generates photorealistic images using deep neural networks. For example, in NeRF, we begin by capturing photos from various viewpoints. These photos serve as the training dataset for the neural network that represents the 3D space. Once the network is trained, the NeRF model can generate the images from any viewpoint. Now, let me explain how NeRF rendering process works. To render an image from a novel viewpoint, we cast the rays to each pixel and sample the points along the rays. These sampled points are encoded to high-dimensional features, and they are fed into an MLP to obtain the color and density information. Finally, the colors of the sampled points are accumulated to produce the RGB value of each pixel. Instant NGP employs multi-resolution hash encoding and demonstrates state-of-the-art performance. However, it still suffers from slow rendering time. On a high-end GPU, it renders Full HD images only at 2 to 10 frames per second. In detail, the encoding stage is the main bottleneck, which takes more than 60% of the total rendering time. To improve the performance of neural rendering, we propose an algorithm hardware co-design in this work. In the original algorithm, the sampled points are accessing the hash table using a global hash function. However, this leads to random accesses across the entire hash table. So, the hardware needs to have a large on-chip memory to avoid irregular off-chip memory accesses. To address this, we propose restricted hashing where the 3D space is divided into small subgrids and the points are constrained to access their own subtables. In this way, small on-chip memory is enough to encode the points. On the hardware side, we propose a specialized accelerator that features a novel hash encoding engine. With restricted hashing, our accelerator performs parallel execution of the encoding and MLP stages, and it also employs two data structures to deal with different hash levels more efficiently. By extending the existing DNA accelerator with an encoding engine, NeuRex achieves up to a 9.88 times speedup over the GPU with substantially small area overhead. For more details, please attend our talk in Session 2C on June 19 at 2:30 p.m. See you there.